Alright, today we're going to talk about evaluating functions. So the problem will generally say evaluate the function at x equals stuff, and then somewhere in that problem they will give you a function. And now the first step in this is to figure out what that number is that they want you to evaluate it at. So at x equals, that number is what we've got to use, and then we're going to put it into the function that they give us. Another way that they might say this is they might say evaluate the function, and then they might say f of, and then that same number will be in the parentheses of the function. And that just means in both of these cases that we're going to replace the x, all of the x's in the function, with that number. So let's see what that looks like. Everywhere there was that x, we're going to replace it with this -3. And I'm going to do it so that my -3 is in blue the whole time. Well, maybe not the whole time, but as I'm putting it into the function that's in black, my number I'm evaluating it at will be in blue, so that -3. So everywhere there was an x, I put the number -3. Now you'll also notice that I put it inside parentheses, and this is going to help us with order of operations. The please excuse my dear Aunt Sally. Pemdas. The reason I put it inside parentheses is because I want to make sure that I do those exponents first. And also, if you get into any more complicated problems where you're evaluating the function, maybe not necessarily at a number, but at a variable with a number or anything crazy, you're going to want to put it inside parentheses, and that helps continue the order of operations better. So I'm starting with the parentheses and exponents. Specifically with the parentheses in this, there's nothing to reduce inside of the parentheses, but it is going to help me now move on to the exponents, and the exponents are on those parentheses, so that has to go first. Once inside the parentheses are reduced, then we move to the outside of the parentheses onto those exponents. So I'm going to raise all of these powers that are there before moving on. So in my next step, the 4 stays, and now I've got to do -3 to the 3rd power. -3 to the 3rd power is -3 times -3 times -3, which is a -27. And now I'm going to keep it inside the parentheses for a little while longer. And that's to make sure that I see that there's multiplication there between the 4 and the -27. Sometimes if we're going fast and we just write 4 -27, you might see it as subtraction, which is going to give you a wrong answer because there's multiplication there. Just like there's multiplication between the 4 and that x cubed. It's 4 times x cubed. So we got to make sure that we keep it as multiplication. So now we're going to move on to the next thing, which is that -3 squared, which is multiplied by that 2. So I'm going to keep it 2 times, and then in parentheses, -3 times -3, which works out to be +9. And then continuing on with the problem, it's -5 times -3, and then +2. To move on from here, oh, my program's freaking out a little bit. Stop. Thank you. The next step, we did the exponents. The M and D of Pemdas is now multiplication and division, and you would do multiplication or division from left to right. Here I don't have any division in this problem, so I'm going to do all the multiplication that I have in this next step. So that's going to be 4 times -27, which is a -108. 108. So 4 times negative 27. The plus sign stays, and now I do 2 times 9, which is a positive 18. And now there's two ways that you could tackle this next part. You can either think of it as subtraction and do the minus sign and then 5 times negative 3. Or what we can do is we could change this to be plus a negative. And so this becomes a plus sign down here. And now I'm going to do negative 5 times negative 3. And negative 5 times negative 3 is positive 15. Either way that you should do this, whether you keep it a minus sign, a subtraction sign, and then do 5 times negative 13, that'll come out to be minus negative 15, and those double negatives will become positive. Either way, the double negatives become addition, and you should have addition at that step. And then now, finishing off, it's the plus, and that 2 that's been staying on stays there. Now, in the last step, we have the A and S of Pemdas, the addition and subtraction. And again, you're going to do addition and subtraction at the same step from left to right. So I'm going to start on my calculator with negative 108 plus 18 plus 15 plus 2. So negative 108 plus, I don't want to write in red. Negative 108 plus 18 is negative 90, plus 15 is negative 75, plus 2 is negative 73, and that gives us our final answer of negative 73. That is our answer. Whenever you're evaluating a function at a number, you should get a number as your answer. So to recap what we did, we took the number that we're evaluating at, which is usually an x value. We put it in for all of the x's in the function. Then we follow order of operations to reduce the problem, and our answer is a number, a single number. So in this case, it's negative 73. That is our answer. I hope this helps you in evaluating functions. See you next time.